Hello dear participants, I welcome you all here in this certificate course. We are starting lecture number 19 today, and the title of lecture 19 is Descriptive Statistics, Reading and Interpretation of Central Tendencies. As we all know that in lecture 17 we already have seen the process to compute different central tendencies using MS Excel and S.P.S.S. That part already we have covered in the lecture number 17. Moreover, in lecture 18, we tried to understand meaning of central tendency and meaning of different measures of central tendencies like mean, median and mode. Once we all are familiar with the process and meaning of central tendency, now we can lead towards the reading and interpretation of the results. Results which we have computed here, results which we have drawn here in lecture number 17. So the objective of lecture 19 is to make you familiar with reading and interpretation of numerical outputs of central tendencies in MS Excel and S.P.S.S. But before starting the reading and interpretation part, let me revise the meaning of arithmetic mean, median and mode. What is arithmetic mean? Arithmetic mean is the sum of all the observation values divided by the number of observations, and arithmetic mean actually represents the average value from the data set or from the distribution. What is median? Median is the middle value in a distribution, and it is a value located at exactly 50th position, and that is why median is also known as a positional value. Median is also known as a positional value. What is mode? Mode is a value with highest frequency in the data set, and mode is classified into three parts. The first part is a unimodal. What does that mean? It means if we get a single value who is having the highest frequency, then that would be known as a unimodal. If you are getting two values having the same highest frequency, then that would be known as a bimodal. And if we are getting more than two values who are having same highest frequency, then that would be known as a multimodal. Then we already have discussed a few important questions. We tried to answer all these questions in the previous lecture. Now let me take you all to the reading and interpretation of the central tendency, and for that I'll take you all to the same data set which we have referred in lecture number 17. So here is a data set, and on the same data set we already computed. Using the same data set, we already computed central tendency in MS Excel and in the S.P.S.S. Results are same. You can refer to S.P.S.S results or MS Excel results. Here, so far this lecture is concerned, we are going to refer the MS Excel results. In this data set, we are having different variables, and more specifically, we are having two nominal variables. They are gender and gender C. We are having two ordinal variables, satisfaction and satis, and we are having six scale variables. They are age, height, weight, income, family member, and per head income. Moreover, this age C we are going to consider as an ordinal variable because this is a coded data. This is a coded data. All these values, all these numbers, they are representing the results associated with respective central tendencies like mean, median and mode. All procedural part already we have seen in the lecture number 17. So we'll not much talk on the procedure, but we'll explain you that how can we read and interpret these values. So let me start first with the nominal variable. Here is a nominal variable gender and gender C. Now if I try to compute mean, median, mode on this variable gender, I'll get the error message in MS Excel. And in S.P.S.S also, S.P.S.S also will not able to compute mean, median, mode for this gender. What is the reason? Reason is that this variable is actually a string variable. All the responses here are recorded using words or using alphabets. That is why we cannot treat alphabets here. We cannot give statistical treatment on the alphabetical data. That is why we are getting error message here. So we'll now shift to the gender C, and let's try to read and interpret the result here. I'll start from me. What does that mean? 0.46. How to interpret this? Can I say that my respondents, they are neither 0 nor 1? If 0 is associated with male and 1 is associated female, then can I make a statement like my respondents, neither they are male nor female, but they are in between, because this value 0.46, it lies between 0 to 1. I cannot make such statement. If you go to software will compute something, it will give some number, because for software all they are just simply the numbers. But for me, this is my variable gender C, and I know that there means the attributes here, they are mutually exclusive. One is male, other is female. Fine. So I cannot give meaning to this result 0.46. And in simple terms, mean is not suited for nominal variable. Now come to median. What is median? 0. What does that mean? A person, if I arrange this data in ascending order, a respondent who stands at 50th position, who stands at the mid of this distribution, his gender is male. So that's it. I can give only that meaning. Whether that meaning is very significant for my research or not, it depends on your own objectives and the many other things. But if I say median also is not suited for nominal variable, it is also not suited for nominal variable. Now come to the last, that is mode. Now what is mode? Here the computed value for mode is a 0. What does that mean? It means that most of my respondents are male, because 0 is assigned code to male. Now here is some kind of meaningful statement that we can construct. Fine. Mode is more suited to nominal variable. Now can we show mode using chart? Yes, absolutely. We can show it using chart. Here this bar is showing the mode. Here 54% respondents are male, that is why my mode is male, that is 0. So this is the way that we read and interpret central tendency result for nominal variable. Now let me take you all to the ordinal variable. Again the story is same. If you are having alphabetical responses, string data, then we are going to get the error message. We cannot give statistical treatment here on this variable. So instead of this, we will now shift to statistic. Now again here, what is mean? Mean represents the average of something. Now average respondents said that they are not satisfied nor neutral with 2.61. If you remember, code 1 we have given to very satisfied, code 2 we have given to satisfied, 3 to neutral, 4 to unsatisfied, and 5 to very unsatisfied. Now when I am saying 2.61, 2.61 lies somewhere here, then how can I make a statement that average respondent are saying they are not satisfied or nor neutral? Means it's kind of confusing thing. So I cannot interpret this. Median. How to interpret median? Median result is 2. It means a respondent who stands at 50th position, he quoted that he is satisfied. That's fine. Here sort of meaning I can provide here. But when I'll come to mode, then it gives more significant meaning. Here we can give more fruitful meaning. Like mode is 2. What does that mean? Most of my respondent are satisfied. They are satisfied with the product or the service, whatever is the question is. So mode is more again suited to ordinal variable. In some cases median is also suited for the ordinal variables. Now let me take you all to the further thing. We can show the mode here using the graph. Now here also comparing graph and these numbers, can I say 2.61 where it is like 2.61 somewhere here? I cannot give meaning to this point. I cannot give meaning. For median, that's fine. I can give some sort of meaning for this two also, because this is mode. Mode and median are suited for ordinal variable, but mean is not suited for ordinal variable. Now let me take you all to the scale variable. Here is the age data Fine, and this is a coded age. Now what is the meaning of this? The average age of my respondent is around 37. 36.94, almost 37. Fine. Median age, a person or respondent, if I arrange this data in ascending order, a person who stands at the mid of the distribution, his age is 36. Mode 36, the highest frequency, age having the highest frequency is 36. Here we can see 36, 1, 2, 3, 4, 5, 6, 7. So there are 7 respondents who are having the age 36, and all other ages are having less than 7 respondents or 7 as a frequency. Fine. So this is the way that we can read and interpret the result for scale data. Here the mean is suited for scale variable, and this is a very important statement. Here this mean is very important. For scale variable, we can give some proper meaning to the arithmetic mean. If we are having the scale variable, and if we compute arithmetic mean, then we can give some proper meaning to this number. Fine. Now if I come to age C, can I say that miss, if you remember, we categorized it like this: code 1 is assigned to 10 to 20, then 2 is assigned to 20 to 30, and so on and so forth. So again, if we are having the categorical data, we cannot give meaning to this part. No. If you are having categorical variable, then mean will not work. Arithmetic mean will not work. Median, that's fine. A person, a respondent who stands at the 50th position, he lies between the age group of 30 to 40, because this is a code 3 is a code assigned to 30 to 40 age group. Mode is 3. Most of my respondents, they lies between this group 30 to 40. That's fine. I can say that. But if you are having the scale variable, arithmetic mean will work here. If you are having the categorical variable, coded variable, then mean will not work here. Fine. Now let me take you to the graph. If I go further, here is a histogram, and in this histogram you can see that my mean, median and mode, where they lie, 37, 36, 36. So here it is around 36, 37, 36. So all they lies here somewhere. Why we call it central tendency? Because we tend to go to center, and we try to find a value which represents the center of this data, Now let me draw the other chart for this age C. Now in this age C, again, that's fine. Median I can understand, mode also I can understand, but this mean 3.19 will lie somewhere here. I cannot give meaning to this point. All these points for age, they will lie somewhere here, and I can give some meaning to these points, because this is a continuous frequency distribution. Here this is a histogram, this is a bar chart or a column chart. I cannot give meaning to these numbers. Fine, because these all are the discrete values. So this is the way that we read and interpret the data or the result here in the scale variable. Now if I plot all these frequencies, this 16 is somewhere here. Fine. 61. So if I plot all these frequencies here using all these circles, now you can see that mean, median, mode, 36. Where is the 36? Here is a 36, and here is 37. So here is mean, median, mode, all they are here in this thing, and we are trying to find a value which represents the center of this data. And what is the center of this data? This is the center of this data, and from this center we are trying to find out the central tendency, that is mean, median, mode. And what is mean? Average age of my respondent is 37. A respondent who is at the middle of this distribution is having the age 36, and 36 is the age with the highest frequency. 36 is having the highest frequency. So this is the way that we read and interpret the results for the scale variable. Now let me take you to the next scale variable, that is height and weight. Here again average height is 168. Average height is 168, round figure, because 167.87 round figure is 168. The median height is 168 and mode is also 168. So average height of my respondent is 168 centimeter. Fine. The highest frequency of the height is 168 centimeters. This is the way that we go with height. What about weight? Average weight of my respondent is 65 kg. A respondent who stands at the 50th position, if I arrange this data in ascending order, then his age is 66 kg and the highest frequency age is 67. Highest frequency age is 67. Now if I go and draw graph for height and for weight, we can find that 168, where it lies somewhere here, right? This 168, 168, 168, it lies somewhere here. Means we try to find a value which represents the center of this data, and center lies somewhere here. Fine. Story is same with the weight. Yes, 65, 66, 67. Where are they? 65, 66, 67. Around here somewhere. Fine. Here also we try to find a value which represents the center of the data. Center of the data. That's the meaning of the central tendency. And all these graphs been imported from the S.P.S.S output. Fine. Fine. I hope you understood this, how to interpret. Now come to the income. Again the same thing, mean, median, mode. 34,000 something is the average income of my respondent. Median is 31,500 and mode is 28,000. Now if I draw a diagram, it looks like this. Again here also my mean, median and mode, they are somewhere here at the center. It represents the center of the distribution. Fine. Now let me take you further. Family members. Now can I give some meaning to this thing? As I mentioned, if you are having scale variable, no doubt we can go with arithmetic mean. But sometimes here family member, it is actually an interval scale. Interval scale is a part of scale. Interval plus ratio together is known as a scale. But here, so far my variable is concerned, members in a family is a discrete data. And here, if I try to give meaning to this value, then it is quite difficult. Can I say that the average family members in my, means so far my respondents are concerned, they are 3.5. Is there any family who is having the members in family 3.5 family, or 3.5 kids are there? No. Either we are having 3 kids or 2 kids or 1 kids. Either we are having 3 family members, 4 family members. We are not having 3.58. Fine. Now to give proper meaning to this 3.58, what I'll do, I'll round figure it to 4. And then I'll say the average size of family member, average size of family of my respondent is 4. I mean there are 4 members, averagely 4 members in a family of my respondent. So this is the way that I can interpret this. Median already we know, mode already we know. Here is the mode. 32 respondents with the 4 members in a family. That is why this bar with the highest height is known as a mode. Now let me take you to the further scale variable per head income. Again we have computed mean, median, mode. Here is the histogram. Here is one interesting thing. 10,577 is the arithmetic mean. That's fine. But here is one value which is a very different, and this value is known as a outlier. Outlier. We'll talk much on this outlier little later, but this also plays a very important role here in the central tendency. It affects the mean. It affects the mean. If there is outlier, then it affects the mean. Now when there is outlier in the data, then it is always better to go for median. It is always better to go for median. Why it is so? That we'll discuss in the upcoming slides. Let me go ahead. So here is the outcome, and we we have we already have talked on all these values, and we have tried to read and interpret all these values. Fine, I hope you understood all this part. Now let me take you further. So this is the way that we read and interpret mean, median and mode for nominal, ordinal and scale variable. Now here is the output, S.P.S.S output and MS Excel output. As already mentioned, that you, as per your comfortability, you can use MS Excel or S.P.S.S. They both gives you the same result. All these numbers, they are matching. 0.46 is here, 0.46 is here, 36.94 is here, it is here. So only the process is different. The design, it appears it may differ, but all these numbers, all these results are same. All these results are same. For example, for gender, here is the error message. Here SPSS means there are no values. SPSS is not able to compute mean, median, mode for this gender. Here also for satisfaction, here is a error message, here it is empty. But you go to any other column, all those numbers are present in this also. So there is no as such difference in the result of MS Excel and SPSS. It is up to you. If you are comfortable in MS Excel, go with MS Excel. If you are comfortable in SPSS, go with SPSS. No problem at all. Now let me take you to the concluding part. Mean provides characteristic value, more appropriate for scale variable. Mean, arithmetic mean is more appropriate for the scale variable, that already we have seen. It is a center of gravity, balancing the values on either side of it. It does not vary too much when a repeated sample are taken from the sample population. What does that mean? Suppose here is a particular region, and from this region I have selected some samples and I have computed arithmetic mean, and a particular number came. Suppose say that 52. This is age. Now someone else comes in and he also works on the same topic, and he also choose samples from the same population but using different scientific method. Now if he choose different samples and if he compute mean, his mean will not be means the difference between these two means will be not significant. There will be no means a very, that difference is not significant. If you are choosing samples from the same population, then that mean will not differ much. So it does not very much, it does not vary too much when repeated samples are taken from the same population. And that's the beauty of this arithmetic mean. Mean is not position value like median. It is calculated using rigid formula, because in mean we add all the x. So arithmetic mean is the only measure who is having the rigid formula. It leads itself to subsequent algebraic treatment. Yes, once we compute mean, then we can go for the further statistical treatment. Mean is affected by extreme values in the data set. Outliers. What does that mean? Let's see with one example. Suppose here is the data of monthly income, and here are the respondents. 7 respondents are there. Now if I compute mean using average function or formula, then what is my mean? My mean, arithmetic mean is 17,429. Then how to interpret this? I can simply say that average monthly income of my respondent is 17,429 rupees. But if I observe the values, see here is 2,600 and 5,000, 7,000, 6,000, 4,000, 8,000. There is only one respondent who is having the monthly income 90,000 rupees. Very high. Whether this 17,000 represents all the respondent? Answer is no, because here it is an outlier. This is an outlier, and if I draw a line, like this, and in this line say that here is a 19,000 rupees, and here one is 2,000, other is 6,000 rupees, then 4,000 rupees, 5,000 rupees, 7,000 and 8,000, all below 10,000. correct, then 20,000, and so on and so forth. So majority of my respondents are here and only one respondent is here. But this response has affected my mean, and mean is 17,000. 17,000 is somewhere here. 17,000. But it doesn't represent the center. It doesn't represent central tendency. Whether the 17,000 represent the center of this data? No, it is not, because most of my respondents are having less than 10,000 rupees as a monthly income. So in this case, if we are having the outliers, then we should go for median. If we are having the outliers, we should go for median. What is median? Median is a positional value. The place of median is at the mid of the distribution. Extreme values do not affect median. That's true. If we are having the extreme values, then instead of arithmetic mean, we can go with the median. No problem. More appropriate for ordinal variable. Median is actually more appropriate for ordinal variables. But if we are having extreme values in scale, we can go for the median. No problem. Median is not determined by each observation, not capable for further algebraic treatment. This is very important. If we are computing median, whatever value we'll get, we cannot go for the further. We cannot go further for the statistical treatment. It may vary when repeated samples are taken from the same population. This is also very important statement. As I mentioned, from a particular region, I have selected particular samples. Then my mean will be approximately same like the mean from the other person. But in case of median, if I compute median, there are heavy chances that my median will not be same like the median second time someone has collected data and computed median. Fine, because here median is a positional value. Median is a positional value. Mean is more powerful measure of central tendency than median. That we can say. So again here, if you are having the extreme values and if I compute median, you can see that what would be the median? 6,000 rupees. Fine, 6,000 rupees. How to compute median manually? Simply, median is equal to size of n plus 1 divided by second item. What is n? Number of observations are 7. There are 7 number of observations. 7 plus 1 divided by 2. Then 8 divided by 2. Then it would be fourth item. It would be fourth item. And to identify the fourth item, what is the procedure? First, you will have to arrange the data in ascending order. For that, I have arranged this data in ascending order, and then I'll count fourth item, first, second, third, and fourth. Either I can start from this place also, 1, 2, 3, and 4. So fourth item is 6,000. That is why my median is 6,000. Fine. So this is the way that we go with median. What is mode? Mode can be determined graphically. Yes. If the curve or column or bar reaches a maximum level, then it represents mode. It is Mode is also not affected by extreme values. It is also not affected by extreme values. Mode is not based on each and every value in the series that we have seen when we computed manually. In some cases, mode is bimodal or multimodal. This also we have seen. Mode is not helpful for further algebraic treatment. If you remember, median and mode, they are not useful for the further statistical treatment, but mean, if we compute mean, yes, we can go for further statistical treatment. That is why mean is considered as a powerful measure of central tendency than median and mode. But median and mode are having their own importance, and it depends on your variable and the way you actually want to analyze your data. Accordingly, we can choose appropriate central tendency, measure of central tendency. Now here, how to compute mode? Simply, I'll use the function mode. I'll select the range, and you'll find that error message appears because there is not a single value which came at least twice. Fine. And for that, what I'll do, I'll change some data. I'll just rearrange data. Instead of 5,000, if I just put 6,000 here, then I'll find my mode is 6,000 rupees with the highest frequency. Fine. So the question comes now, all the three are central tendencies, mean, median and mode. All the three are the measures of central tendency. But when to use mean, when to use median and when to use mode is a very important question. To answer this, here is one table. If we are having the scale variable and if the distribution is normal like this, there is no outliers, there are no extreme values like this or like this, fine, then we can go with the arithmetic mean. If we are having the scale variable, we can simply go for arithmetic mean. If we are having the ordinal variable and skewed or extreme values, then we should go for median. If you are having nominal and ordinal, and if you are having skewed or extreme values data, then we can go with mode. In arithmetic mean considers all the values. Median and mode, they don't consider all the values. We can go for further algebraic treatment once we compute the arithmetic mean, but if we compute median and mode, we cannot go for further algebraic treatment. Whether your arithmetic mean is visible in the data, whether the computed mean is visible in the data, it depends on data. Sometimes it is visible, it is there, its presence is there, and sometimes it is not there. If you are having odd number of observations, your median is visible, its presence is there in the data. If your number of observations are even, it is not visible, its presence is not there. So far mode is concerned, yes, absolutely, mode is visible in your data. Its presence is there. Arithmetic mean presents average value, median presents 50th positional value, and mode presents most frequent value. For arithmetic mean, we use histograms. For median, column or bar charts are suited, and for mode, column or bar or pie charts are suited. So this is the way that we read and interpret measures of central tendencies, that is mean, median and mode. I hope you all understood this lecture and you all enjoyed this lecture. So far this lecture is concerned, we'll stop here. See you soon in the next lecture. Thank you.